Welcome to this short discussion about floating foundations in Chicago architecture construction and caisson foundations or pile foundations. My name is Jim Janessi. This is part of the first year program at DePaul University. This course is Explore Chicago Architecture through Digital Photography, and this is one of several subjects that we're taking a look at in connection with Chicago architecture. Here is a kind of a cartoonish picture of a small steel frame building. The steel frame is illustrated by these red members, painted steel perhaps being used in construction, and what you see here is a typical way that early steel frame buildings were constructed. The building is held up by a foundation that consists of kind of a raft of maybe steel beams embedded in concrete or even railroad ties and railroad track, as in the auditorium building, and the steel members stretch all the way down to that foundation. The purpose of this foundation is to spread the weight of the building evenly. If these steel members just poked into the ground, they would sink. They don't have much surface area, and they would just sink right into the ground. So the foundation had to be broadened, and finally John Wellborn Root came up with the idea of having a foundation that was continuous, perhaps even spread out past the edge of the building, so that somehow the entire weight of the building borne by these steel members would be spread. And if the architect were lucky, then the moisture in the ground and the softness of the ground in various areas wouldn't vary too much down here in the dirt, and this building was expected to settle, but it might settle evenly if they were lucky. Now there is a layer of bedrock underlying Chicago. It's 40 feet down or perhaps further, but there wasn't a very convenient way of reaching it with the technologies available for excavation in the 1880s, so many buildings were constructed this way, and some did. They all settled, and some settled in rather unusual ways. We have here the kind of settling that might have occurred if they were lucky. Notice I'll go back to the earlier slide. Here was the way the building was constructed, and as the weight piled up on top, it eventually might sink a few inches, or in the case of the auditorium building, the foundation walls are so heavy it sunk 29 inches. Now that's really pretty dramatic. However, if they were not very lucky about things, the building might sink something like this, in which case, depending on the amount of uneven settling, things were kind of bad. And you will see some buildings like this. On Michigan Avenue there's one that's a notable slant to the window. On Wabash there's also another. And some buildings attempted to correct for this by making cosmetic changes to the way the window frames worked and hoping that the building wouldn't settle any further. Many of the old structures are now taken down because the land became more valuable than the rents that could be earned in such a small leaning structure, and it was eventually demolished. Something better had to be done. Well, let's take a look at a building that had properly settled. Let's suppose it were constructed instead using a caisson foundation or some type of pilings that actually reach down to the bedrock. The bedrock is solid. It's not about to sink unless we have a major earthquake, and then it's all up for grabs. So the bedrock is where tall buildings have to be anchored. The taller they went, the heavier they got, and the less stable they would become if you tried to float them, as this building indicates. So here's what was done. Around 1900 they were experimenting with this. It actually got perfected into the 1920s as buildings reached even higher than 18 stories. This sort of construction adds columns here which are unseen. They've been drilled through the earth, and perhaps they've been spread out where they contact the bedrock. But these are concrete columns that can bear a lot of weight, and in order to strengthen them further, steel cages, reinforced steel, is put into here. So these caissons reach all the way from the level of the earth down to bedrock, and that's actually what the steel members rest on. So whether the earth shifts a bit under this, it has no consequence whatsoever, because the real weight of the building is being borne by the bedrock here. And all the large structures you see in Chicago, anything above 18 stories or so, and frankly any modern construction, even like the L, when the new platforms were put in at the Fullerton stop, caissons were used all the way down to bedrock to make the L a lot more sturdy than perhaps taking the chance that a floating foundation might sink unevenly in various areas. So how are these caissons actually constructed? Let's take a look at that. What happens is Normally, some type of a liner is driven into the ground, some sort of a tube, heavy steel, very heavy steel, perhaps an inch thick, is being driven by some sort of a hammer into the earth and down to bedrock, and that forms a casing. It's sometimes this thing is called a vibro hammer, some sort of a device that puts a very strong vibration into it, helps it cut through the earth. There may be some edges down here. This may be rotated to sort of bite its way into the earth, and between the weight and this circular motion it sinks down to bedrock and forms this sort of a lining. In this case, the lining didn't reach all the way to the bottom. Whether or not it does is kind of immaterial. It has to go far enough to get to the point where this bottom might flare out. And then some sort of an auger is used to drill down, pull out some earth, pile it off to the side so this crane will swing around, and it drops this auger farther and farther down, and fairly quickly it can drill down. These blades may be 5 or 6 feet wide. This is a very typically that would be a very wide caisson, but they may go that wide, and all the way down to the bedrock, and then a different bit is put on here to cause a flaring out most of the time at the bottom to settle it better. Then a steel cage is lowered into it all the way to the bottom. This steel cage is kind of circular, and it's composed of reinforcing steel wired together or welded together, and it drops all the way to the bottom. And then some type of truck is brought up to dump concrete in buckets and to fill this hole up. And then usually something is pushed in there in the way of a vibrating stinger sort of a device that jiggles the concrete quite a bit to get the bubbles out of it so that it makes a very firm, solid concrete. The cage is left in there, and the concrete is left to settle, and the vibro hammer then is used to jiggle the casing and pull it out. So what you're left with is this solid concrete with reinforcing steel in it, and it's all hidden in the ground, and it's just a hole that diameter that's been dug down to bedrock. So now this provides a very firm footing for a very tall building, as tall perhaps as the BP building used to be called Amoco, or any of the other large structures you see, the John Hancock building, the Sears Tower, and buildings of lesser height. They're all anchored into bedrock in this way. That's as much as I'm going to tell you about foundations. My name is Jim Janessi, and that's the end of this little video.